Welcome back to electrochemistry. Today we're going to be talking about redox titrations. This is the same kind of titrations as we did with acids and bases, but now we're doing it with redox reactions. Let's get started. So the first thing you need to be able to do for redox titrations is balance a redox reaction. In fact, I'm not even going to look at that problem yet until I got an equation that is balanced. For example, I see that there are 4 oxygens on the left-hand side and no oxygens on the right-hand side, so this equation is not at all balanced, and we need to get that done first. So, I'm going to split the reaction into half reactions. There is an iron half, and then there's also a manganese half. And so, starting with the iron half, that's going to be Fe plus 2 turning into Fe plus 3. And then the manganese half will be MnO4 minus turning into Mn plus 2. So for the iron half, Fe plus 2 to Fe plus 3, I need 1 electron. It's going to have to be on the right-hand side in order to get everything to balance. That'll be a total of 2 pluses on the right and 2 pluses on the left. For the manganese, it'll be a little trickier. Since there are oxygens on the left, I'm going to have to add something with oxygen on the right. And if you'll recall, that'll be water. And since 4 oxygens, then I'll need 4 waters, because that contains 4 oxygens. Well, by doing that, I've introduced hydrogen on the right, and so I need to introduce hydrogen on the left, and since this is an acidic environment, hydrogen is H+. 4H2 means 8H+. And now that I've got that, I'm going to look at the charges. So far on the left I have 8 pluses and a minus. That's a total of 7 plus. On the left I have 2 plus. In order to get 7 plus to equal 2 plus, I'm going to need 5 electrons. And that way I've got, let's see, 5 minus and 8 plus and 1 minus. That's a total of 2 plus. And then on the right hand side I still have 2 plus, so all of the charges balance. So now I have 2 balanced half reactions. I need to turn that into a whole reaction. Since we have 5 electrons for the manganese and 1 electron for the iron, I'm going to multiply the whole iron by 5. And that'll give me 5 plus 2s and 5 plus 3s and 5 electrons, most importantly, so that we can cancel. Alright, so now add them all together. Everything on the left, everything on the right. If it's on the left, it's on the left, and if it's on the right, it's on the right. Plus 8H plus MnO4 minus turns into 5Fe plus 3 plus Mn plus 2 plus 4H2O. And we have magically a balanced equation. Ta-da! Now we can look at the actual redox titration. So there we are. 8H plus, 5Fe plus 2, MnO4 minus, 5Fe plus 3, Mn plus 2, 4 waters. How many milliliters of 0.5 molar FeSO4 will react with 25 milliliters of 0.2 molar KMnO4? Well, the KMnO4 is pretty easy to see because you've got MnO4 right there. So 25 milliliters of 0.2 molar. But the FeSO4, which iron is that? Did you remember that sulfate is a -2 charge, which means that this iron is talking about is a +2 charge. So we're looking here for this iron, and that is question mark milliliters of 0.5 molar. So you kind of want to do MAVA equals MBVB, like we did with the acids and base titration. It's going to be a little bit trickier than that. First of all, we don't have acids and bases, but also because there's some stoichiometry issues here with the mole-to-mole ratio. So instead, we're going to say M1V1, M2V2 divided by moles 1 divided by moles 2. The way you're going to use that equation is, let's just call the Fe 1 and the MnO4 2, just for simplicity's sake. So the molarity of the Fe is 0.5 molar. The volume of the Fe is what we're looking for. The moles of the Fe from the balanced equation is 5. The molarity of the MnO4 is 0.2 molar. The volume is 25 milliliters. And the moles from the balanced equation is 1. We're going to cross multiply. That is, multiply what's across and divide by what's left. 5 times 0.2 times 25 divided by 0.5, and we end up with x is equal to 50 milliliters. And there we go. That is redox titration. Let's try another one. So first thing we're going to do is balance this reaction. And this one's already split up into half reactions for us, so we just got to balance. I'm going to start with the MnO4 because I just did that one in the last problem. I remember that I added 4 waters on the left to get the oxygens to balance, and I remember that I added 8 hydrogens on the right to get the hydrogens to balance, and this is still an acidic environment. And then I remember, since there's 8 pluses and a minus, and over here I've only got 2 pluses, that I need 5 electrons to get that MnO4 balanced. So now what about the H2O2 and O2? So I see that there are the correct number of oxygens on each side, but not the correct number of hydrogens, so I'm going to start with hydrogens. Again, since it's an acidic environment, I will add 2 H pluses on the right-hand side. And now I need to balance. I've got a 0 charge here and a 2 plus charge on the other hand, so 2 electrons. Now that I've got my 2 reactions, now I need to add them together, but notice that there's 5 electrons for the MnO4 and only 2 electrons for the H2O2, so we're going to multiply the H2O2 times 5 and then the MnO4 times 2 to get the electrons to be equal to 10 in both cases. And that way the electrons will cancel. So when I do that, 2 times 8 gives me 16 H pluses, 2 MnO4 minuses, 2 Mn plus 2s, and 2 times 4 is 8 waters. 5 times 1 is 5 H2O2, 5 O2, 5 times 2 is 10 H pluses. So, to clear that up a little bit, I ended up with 5 H2O2, and no electrons because they canceled, 16 H pluses, 2 MnO4 minuses, 5 oxygens, 10 hydrogens, 2 Mn plus 2, and 8 water. Ooh, that doesn't look like 8 water. Okay, but now if you're looking at that, hopefully you see there's 16 hydrogens here and 10 hydrogens there. These 10 will completely cancel out. These 16 will turn into 6. So now my new overall balanced reaction with everything canceled the way that it should ends up being 5 H2O2 and 6 H plus and 2 MnO4 minus makes 5 O2 and 2 Mn plus 2 and 8 waters. And there's my balanced equation. Yay, a balanced equation. Now you've got the titration part of it. Pause the video now, do the titration part of it on your own, and come back to me. Did you pause? I hoped you paused. Okay, so we've got 35 milliliters of KMNO4, 35 milliliters of KMNO4, reacting with 30 milliliters of H2O2. And so for the H2O2, 30 milliliters of 0.1 M. For the MnO4, it's 35 milliliters of question mark M. And that formula was M1V1 moles 1 and M2V2 over moles 2. And for simplicity's sake, I'm going to make the hydrogen peroxide the 1 and the MnO4 the 2, and then just plug in. Molarity of hydrogen peroxide is 0.1 molar. Volume is 30 milliliters. The moles from the balanced equation. Save.